Hi, it's time for another math easy solution. Time to discuss further into the point to line distance formula, and now look at yet another derivation. And this one, I'll call this one an alternative formula. The formula looks different, but it's still nonetheless the same. You just got to reword it later on, but it's a very interesting formula, and we'll just jump right in. So just as in the algebraic and geometric proofs, and you can see those in my earlier videos, I'll put that in the description below. This proof is only valid for slanted lines, but nonetheless the final result applies to both horizontal and vertical lines. So we'll just look at the slanted one here, and you can see my earlier one on algebraic to get the horizontal and vertical one, which still nonetheless applies to it. So this time we will use the more popular equation of a line, which is, well, this one, y equals mx, usually written as mx plus b, but I'm going to use k because I'll use b later on in this video. And recall that the m in this case is just slope, and this one is the y-intercept, like that. And this is usually written like this, the equation of a line, as opposed to the more general ax plus by plus c equals 0, as I went over in my earlier videos. Yeah, so now that we have this equation, I'll be using that. So if we have an equation or a line with that equation, first now recall that the line from a point that is normal or perpendicular to another line, or not a like that, to another line is the shortest distance, and the slopes are negative reciprocals of each other. And what I mean by that is, well, let's just draw this all out like this. If we had an x y axis like that, and let's say we had a line such that is like this, and we'll call this this line right here has an equation y equals mx plus k instead of b. So then where the m is the slope, is just a rise over run m1 like that. Where the run is 1, the rise is m. Now if we add a point here, I'll just call this point P across here, and I'll write this as P x0, y0. Now here I just move this around here to be a bit neater. So now the shortest distance from here to here, or this line, is going to be the one that's perpendicular to it. So it's going to look something like this, where it's normal or perpendicular to this other line like this, and I'll call this point, or the distance, is d like that. But again, if we just extended this and considered it as a line, just to keep extending it, the slope here is going to be a negative reciprocal. So it's going to be negative 1 over m of the perpendicular line across over there, and over 1 like that. So then I'll just put this down there. This is a negative reciprocal. Negative reciprocal like that. Yeah, so then the equation of this line across here, this one's going to be just y equals m, where will the slope, so y equals slope times x, and the slope's going to be the negative reciprocal of that, so that equals to negative 1 over m, and then x, and then the y-intercept's going to be, I'll just write this as k2. So that's the equation of this line, and this one is there, y equals mx plus b, and I'll call this line L1 like that, just circle it, and then this one here L2, just for reference, like that. So that line is L2. So now if we look at L2 in more detail right here, we can find out the K2 term, and also, I was going to say M, actually we can solve this because we know this x0 and y0. So for L2, like this, we know that, well, x0, y0, or the point P, is on y equals 2 negative 1 over m x plus k2. So it's on there, that's just on this line like that. So then we could just plug in the numbers. We have y0 equals to negative 1 over m x0 plus k2. So we can move this over to that side. Then what we get is k2 is equal to y0 plus x0 over m. And then what we can do is, well, throw this k2 value inside there, and then what we get is, write it down here, we get y equals to negative 1 over mx plus k2, which is y0, plus x0 over m, and let's move it over like this. Now what we could do is, well, this is common denominator, we could just add those together or factor out the 1 over m. So then this just equals to, simplified out, this is going to be x0 minus x, let's add those up, over m plus y0. So there is the equation of the line perpendicular to the other line. And now what we can do is, well, if we look at this intersection point, we can actually solve for that. So this one, I'm going to write this as coordinates x1 and y1, like that. So if that's the coordinates x1, y1, what we can do is write at the intersection like that. And so at the intersection where we had something like this, yeah, it's perpendicular like that. I'll draw this just a bit better for reference. So at that intersection point over here, we know that, well, x is equal to x1, and we can solve for it. So we could set the lines equal to each other. So what we'll have is y equals to mx plus k is equation of this line right here, L1, and this one is L2. So then this one has to equal to, on this side, they both need to be the same formula, so x0 minus x over m plus y0. So what we can do now is just solve for x here, solve for x, like this. So to solve for it, well, we could just simplify this. What I'm going to do is multiply by m on both sides, multiply by m, put a dot, m like that. So then drag it down here, and then what we have when we do that, just to get rid of this m over there, m squared x plus km equals to x0 minus x plus my0. So now what I'll do is I'll move this negative x on this side, becomes positive, move this km over there. So yeah, move the km just so that we have the x's on the one side. So we have an m squared x plus x equals to a x0 plus my0, and then minus, I'll put the m in front, mk. So I'll just put that m in front, mk, just to make it always the same. And now if we go to the this side over here, we can just factor out the x, so that's x m squared plus 1, like that. Now we can just divide this out over there, and then we finally get x, which is equal to x1 at that intersection point, equals to x0 plus my0 minus mk all over m squared plus 1, like that. And now to get the y point of it, that's just y1 or y1 of x1. This just equals 2. Well, you just plug in the formula. Yeah, you can plug in for either. I'm going to pick this one right here, just the y equals mx plus b, or mx plus k, like that. So we can just plug that inside there. It's just simpler. So we have now y mx1 plus k. And now the x1 is over here. I'll circle this whole thing there. We could throw that inside there. Now this equals to m, and now we have this multiplied by, put a giant division plus 1, like that. This is x0 plus my0 minus mk, and then we need to add a k there, plus k. Yeah, so this is the y coordinate over there. Yeah, so thus we have y1 and x1. So the next step is, well, if we go back to this, now we could just use a distance formula, or just the Pythagoras right here. So if you go down here, make a triangle across like that. This distance across here, this is just the absolute value of x1 minus x0, and this distance, the vertical one, is the absolute value of y1 minus y0. So in other words, we could just use Pythagoras. So what we'll do is recall the Pythagorean theorem. We'll just write Pythagorean Oris like that. Yeah, so if we recall Pythagoras, we have, well, d squared equals to, and then the difference of the sides squared. So we have x1 minus x0 squared plus y1 minus y0 squared. And then we know that those are these ones here, and there's the y1, so we could add those inside. So we get now a giant formula like this. So we have a x0 plus m y0 minus mk like that, and then divide this by m squared plus 1 minus an x0. And what I'll do here, this is going to be, well, we're going to square it. I'm going to just multiply this by x squared plus 1 divided by, I mean not x, m. Just we're not changing anything, m squared plus 1, just so we have the same common denominator. I'm just doing that all in one go over there. Let's put a regular bracket like this, and then we have to add this side over there plus, put it over here, plus x, actually it's not x0, it's m times x0, because we have to do y1 minus y0. So we have m multiplied by x0, that's just going to be this one there, my0 minus mk, this would be a bunch of algebra right here, plus m1 minus, now, oh, we have to do the k, so you can't forget the k. So plus k minus y0, and now we want a common denominator the same one, so what I'll do is do the same thing to this side. I'm going to put a bracket, multiply this by m squared plus 1 over m squared plus 1, so we're not changing anything, and then squaring that. Yeah, so we have something like that. I'll put this dot here so that we're multiplying both sides, not just one, like that. Yeah, not just the m squared, just to make it a bit neater. So now we could do the top part. So this all equals 2, and then we could have is, well, there's an m squared plus 1. What I'll do here is we're going to get an m squared plus 1, m squared plus 1 on every single term here, and then that's squared. So what I'll do is I'm just going to take it completely out and out of the square. So this is m squared plus 1 all squared, and now we have just the terms over here. I'll put this giant bracket like this because we factored all that out. So now put a regular bracket there. Now we have an x0 plus my0 minus mk minus, now we can multiply that inside minus, I'll put the m squared in front, m squared x0, and then minus x0 like that squared. We can see here this cancels with this, everything else remains the same, and then we have to add on the other side. So let's write plus and put a bracket. Here is going to be, multiply that inside, mx0 plus m squared y0 minus m squared k, and I'll just put this in the center actually, because, well, we don't have this, we already factored out the m squared plus 1, and then all squared like that. So now we have is plus, now we can multiply on this side out. We need to FOIL out this by this, and then this by that, so we have m squared k. I'll just put the m in front just for yeah, just to make it easier to follow along. So now, and consistency, so we have k times 1 there plus k, and now we have this y0 times m squared, that's going to be m squared y0, and then negative y0 times 1, that's going to be minus y0 like that, all squared, and then a bracket like that, indicate we've factored those out there. Now we can see what we can cancel out. Well, we have a m squared k and negative m squared k, we can cancel this out. And now the other one we could cancel, well, we cancel this one, m squared y0 and negative m squared y0, so cancel. Now we're left with, well, one term, 2 and 3, and likewise over there we have 1, 2, 3. So this all equals 2, just to simplify this, and then keep the factored out there, m squared plus 1 squared, times it by, put a bracket, another bracket. Now we have this one across, so what we'll have is a my0 minus mk minus m squared x0 like that squared, plus, now we have it on this side, mx0 plus k, and then minus y0, like that, squared, or bracket. Now what we'll notice is these are actually very, very similar, but we have an m here, and this is a positive mx0. What I'm going to do is actually factor out one of the m's and see what we'll get. It's actually quite fascinating. So we'll have is m squared plus 1 squared. Now we'll factor out inside and actually a negative m. So negative m, like this, when we factor it out, and then it's going to be squared there. So we take out an m, but then we take it out, and you also square it over there. This is going to be take a negative out, so put this in front to make it look like that. So we have an mx0, and then we have a negative. It's going to be positive. It's going to be plus, plus k, plus k, like that. That's because we took a negative m out. Now we have a negative out of this one, so we have to have a negative y0, like that, and squared, plus now we have an m x0 plus k minus y0 all squared into it, like that. And notice what we have here. This is actually the exact same thing as this one, so we could factor that out, and this one just becomes m squared. So what we get is, this is an absolute fascinating result. So we have an m squared plus 1 all squared. We factor that out. That's going to be, let's put a regular bracket, mx0 plus k minus y0, and then we factor it out, so we left with an m squared plus a, well, this one's just a 1. Just take it out. Like that. Notice what happens here. This cancels and this cancels. Absolutely amazing. And then what we have is, remember, this whole thing is just equal to d squared. So d squared is equal to, and now what we have is over here, see, I forgot the squared there. So yeah, we factor out the whole squared thing. Yeah, so remember the square there, and we factor and we get m squared plus 1, like that. Those cancel. And now what we have, and also it's usually written with a k in front. So what we'll do is I'll write this as k plus mx0 minus y0 squared over m squared plus 1. Now it's not squared anymore there. So now what we'll do is we'll just square root both sides, and we only want the positive of it because it's a distance. So we get just a positive over there instead of the negative. And then we get d is finally equal to, well, these cancel, and we always want positive. So this is going to be absolute value of k plus mx0, because those cancel there, and we always need an absolute value of distance, like that. And this is going to be square root m squared plus 1, like that, and that's always positive on its own because of the square over there. Let's write this all neater. So there is the formula. Absolutely amazing. So yeah, that is the alternative formula. I'll draw a better box. Now if we want to get back to the normal one, so if we want to note, if we had it, instead the line was, if line is written as, if we just had the line as the usual, ax plus b y plus c equals to 0 is the other more general one. Again, you could rearrange this, move this ax on the other side, we get a negative ax, move the c on there, negative c, divide by b, so we get over b, and this is our formula y, like that. So we can just rearrange it like this, where now the slope, the slope is, I'll just write this down as well. The slope is m equals to, negative ax over b, like that, or negative a over b. So in other words, this just equals to our usual mx. When you rearrange it, mx plus k here. Again, that's why I used k, because we're using a b there. So m equals to negative a over b, and then this is the k over there. So I'll write this like this. This is this, and this one is this over there, and k is equal to negative c over b, like that. So I'll just circle these, and now we could throw these ones all the way inside over there, and this one as well. Throw them inside there, so thus we can get back to our usual formulation for distance. So we get d is equal to So the case switched to that. So we have absolute value of negative c over b, and then plus mx0 plus, or it's going to be negative a over b x0 minus now a y0 like that, all over square root m squared. This is going to be negative a over b squared. That's the m plus 1 like that. And now what I'm going to do here is I'm going to multiply both sides by, well, we want to get rid of this b, but also negative. I'm just going to put a negative absolute value of negative b over negative b like this. We're not changing anything. And again, this just means we're taking the absolute value of it. Whenever you have, let's put this here, recall that if you had x, y, the absolute value of it, this just equals to absolute value of x and absolute value of y, like this. So in other words, we could just combine that inside. So then we have d is equal to, on the top's going to be, well, a negative c over, we put a bracket like this, a b x0 minus y0, then negative b like this, all absolute value around it. And same wise over here, and also this one, this is the same thing as writing, so I'll put that over here. This is the same thing as writing here, no, put a square root like this, negative a squared over b, that's just going to be a squared over b squared plus 1. And now we're multiplying by this one there. That one, what I'll do is I'll square it and then square root it like that. And this is all absolute value, but it's still going to be b. And this is the same thing as writing, well, square root b squared, because everything's going to be positive. The negative's not going to do anything there. So in other words, we can multiply this inside there, and then we can finally get some cancellation out. All the negative b's over here cancel. All the negatives cancel. We're just going to get a positive. So we get an absolute value, and we'll put the this b over here cancel. So we get an a x0. Put that in front, and then we have this one here plus y0 or plus b y0, and then the negative c over b becomes positive c, absolute value, square root. Now the b squareds cancel, we get a b squared there because we have a square root over there. So we can put that inside. We get an a squared plus a b squared, and there is the formula exactly as in my earlier videos using the algebraic or geometric proofs like that. So yeah, absolutely fascinating. So this overall proof I just did now is still an algebraic one, I believe. But it's just an alternative form using the y equals mx plus b or plus k formulation. So there it is. That's what we have. It's the exact same thing. And again, it's for the slanted line, but it still applies for regular lines. It's the same thing as the other one, and I already showed in my algebraic proof that it doesn't matter if it's horizontal or vertical. It still works, but the proof, to be as rigorous as possible, is not valid for that. But nonetheless, the final result's the same. Anyways, that's all for today. If you follow along this pretty tedious derivation, but nonetheless very, very interesting, just to show that you could solve the same problem in many, many different ways in mathematics. Anyways, that's all for today. Thanks for watching. Like always, you can download these exact notes in the link below, as well as viewing these notes on Steemit. Follow me at MES, and I'll also be posting on my math forums, so make sure to go check them out and start posting whatever cool math or science related stuff you find. Anyways, that's all for today. Thanks for watching, and stay tuned for another Math Easy solution.